Yeah, good evening, good evening. Let us wait for 2 more minutes. Good evening, good evening. Okay. From last 2 classes, we are discussing the trigonometric and exponential form of Fourier series. Of course, yesterday we observed the exponential series. What is the general form of exponential series, sir? Sigma Cn e power jn omega naught t. Where we are going for a two-sided spectrum. What is the relation of exponential Fourier series coefficient? 1 by t integral signal multiplied by exponential term. That is the exponential Fourier series coefficient. Of course, we stated C naught equals to A naught. For a periodic impulse train, again we observed the spectrum is another periodic impulse train. Some of the properties we studied, like time shifting, e power minus jn omega naught t naught into Cn. So frequency shifting, how we learned? C suffix n minus m means time domain signal multiplied by exponential term. Then we have taken scaling. X of alpha t means the coefficient remains same. What differs, sir? Only the frequency differs or the time period differs. Omega naught changes to alpha omega naught, but Cn remains same. Then we observe the reversal. X minus t concept is C suffix minus n. Yesterday we discussed the last problem as this year gate model or not. Linked to Parseval's theorem. Then we observed differentiation d by dt xt means what is the multiplier? Jn omega naught times Cn. Parseval's theorem is last one. The total power in a periodic signal equals to sum of squared amplitude of each harmonic. The total power in a periodic signal equals to sum of squared amplitude of each harmonic. So what we proved there, sir? In one of the example, maximum energy or power of any signal is always there only in the low frequency region. Maximum energy or power of any signal is always concentrated in the low frequency region. Whenever we want to get the power up to second harmonic or fifth harmonic blindly, we need this property, Parseval's theorem. Okay. Let us continue. We have to give a conclusion of this topic. Some more models are there. Let us continue. I will wait for 1 minute to go to next slide. In one of the problem we checked full wave rectified sine wave contains only even harmonic components. Full wave rectified sine wave contains only even harmonic components. Okay, I'm moving to next slide, sir. Please think of this question. Some periodic signal is given having its time period as 8 seconds. What is the power in the 10th harmonic is the question. What type of symmetry the signal satisfies, sir? It is satisfying which type of symmetry for us? Odd plus half wave. Half wave is there. Of course, odd. Odd plus half wave. So, sine terms are existing only for which harmonics? Odd harmonics. But power in 10th harmonic, even harmonic is asked. Automatically, what is the answer? 0. Because it contains sine terms only for odd harmonics. But we want power in even harmonic. Answer is 0. It is exhibiting half wave symmetry, odd and half wave. Strictly odd harmonics. Question is find the power in the 10th harmonic, even harmonic. Result is 0. Okay. Please think of this model. The Fourier series coefficient of a periodic signal is expressed as sigma Cn e power j omega naught t. What, Samata? What happened? C minus 2 to C2, those coefficients are defined. It is stated Cn is 0 for mod n greater than 2. After second harmonic, the coefficient amplitude is 0. After second harmonic. With this information, out of the 4 options, which is correct? It is one of the excellent question asked from Fourier series, sir. Fourier series general form is given. Coefficients are defined from C minus 2 to C2. Out of the 4 options, decide the correct one. Think of. Tell me which is correct, why it is correct with reason. You can respond your emotions in the chat box. Which option you feel correct? Out of the 3, only one option is correct, sir. Come on, come on. What old full screen? What old and gold? I am using the same window here. Nothing new. Same window I am using today also. Akhil, you feel A. Kiran Kumar is feeling B. Carry on, carry on. Cover all the options. C and D also. Very good. Only one fellow has given correct answer. Ravi. Listen. One by one reason, listen. Finite energy is wrong because all periodic signals are power signals. All periodic signals are power signals. Any power signal means energy infinity. But the word finite energy is used. Wrong. Second option also clearly wrong. In the problem, what is actual C naught? J2. But that fellow is saying in the option C naught 0. Clearly wrong. Third one is correct because last one is wrong. Both are interlinked option is here. Third one is correct because last one is wrong. What, Surya? Whether screen is visible for everyone? Yes, sir. Please look after from your side. Surya, one more time you log in. Why the third one is correct? The reason is, for the first time in an example, we mentioned C naught is J2, means imaginary. C naught J2 means imaginary. DC value imaginary indicates signal may be complex. We studied under periodic functions, J times e power j omega naught t is a periodic signal. A complex signal can be also periodic. A complex signal can be also periodic. C naught is J2 indicates signal may be complex. Suno. Everyone listen the reason properly, sir. What is general complex signal form, sir? XRT plus J times XIT. C naught equals to 1 by T integral X of T dt is our definition. That is nothing but 1 by T integral real part one term J times 1 by T integral imaginary part. If I substitute that complex signal in the definition as X of T is XRT plus J times XIT, this result is given as 2J. This result is given as 2J. What is the last option mentioned? Real part is even. Suppose in the problem real part is even, we cannot make area under even function 0. Suppose real part is even, sir. We cannot make area under even function 0 with the given information. So the only chance here is imaginary part of the signal is constant. Suppose in the question real part is odd, then that statement is correct. Area under odd signal can be 0. Listen one more time. Finite energy is wrong statement because all periodic signals are power signals which are expecting infinite energy. Why second option is wrong, sir? Because already C naught is given as J2, but that fellow is saying C naught 0. Third option is correct because last option is wrong. They are interlinked. Why the real part is even for this data wrong? We cannot make area under even function 0. So according to the given information, imaginary part of the signal is constant. The compulsory thought everyone requires in the question is what? As C naught is imaginary, signal is complex. As C naught is imaginary, signal is complex. Okay. As C naught is imaginary, signal is complex. It is a beautiful question we got in very old gate paper, sir, 2005, 2006 time. Every option we have to cross check why that particular option fails. The definite thought we require is C naught imaginary indicates signal is complex. That is a definite thought we need, sir. C naught imaginary indicates signal is complex signal. But most of the fellows will feel, according to Parseval's theorem, as Cn is defined only for finite harmonics, they will feel sigma mod Cn square is finite quantity, finite energy. We will never use the word energy for periodic functions. Periodic signals are power signals or not. Okay, let us go to the next model. Let us go to the next model. Now you observe. For the following spectrum, find the power in the periodic signal. Mod Cn angle Cn is given, we want power. What we have to do, sir, if you know mod Cn, how to get power? You know, it is clear indication of Parseval's theorem or not. So complete the first bit. Power equals to sigma mod Cn square. That is C naught square plus 2 times positive range, because for negative and positive frequency, the magnitude levels are equal in the question. For negative and positive frequency, magnitudes are, that is the reason 2 times. So 4 whole square plus 2 into 2 square plus 1 square plus 0.5 whole square watts. Mod Cn is known, asked for power means sigma mod Cn square. Everyone respond for second one. Is the signal even symmetric, odd symmetric, neither nor? Look at the phase spectrum, you'll get the answer. Look at the phase spectrum, you'll get the answer. We clearly studied. Even signal means phase will be 0 or 180. Odd signal means plus or minus 90, sir. That is compulsory. But we have a different phase angle of pi by 4. We have a different phase angle of pi by 4. So neither even nor odd. Neither even nor odd. Even function 0 or 180 compulsory. Odd function plus or minus 90, but we have a different phase angle of pi by 4. Third bit, assuming fundamental frequency of 10 Hz, write the trigonometric form. F naught 10 Hz indicates omega naught is 20 pi, 2 pi F naught. The target of Fourier series is conversion of omega naught to n omega naught. See, sir, here we have shown n only, but we know n is multiple of omega naught. So which are the possible harmonic numbers already? 0 into 20 pi, 2 into 20 pi, 3 into 20 pi, 4 into all n values are multiples of 20 pi. All n values are multiples of 20 pi. How we are converting exponential to trigonometric form? What is the technique we have learned yesterday? To convert exponential spectrum to trigonometric spectrum, what we are doing? For all positive frequencies, take double the magnitude. For all positive frequencies, take double the magnitude and positive sided frequency angle. DC remains same. I hope you have remembered that. It is asked to find the trigonometric form. So that I am writing in the next slide. Indirectly, we want polar form of trigonometric series for that question. D naught plus sigma n equals to 1 to infinity dn cos n omega naught t plus theta n. DC value no change. Here 4 means there also 4 only. Plus. What is the second harmonic? 2 into 20 pi. At which magnitude 2? But how much we have to choose, sir? Double. 4 cos of 2 into 20 pi into t. What is the phase angle to be added? At second harmonic, what is the phase angle, sir? Plus pi by 4. Plus pi by 4. Like that, next harmonic, third harmonic. At which magnitude 1? But take double. What is the phase angle there? Pi by 2. Magnitude double, positive side frequency angle. So 2 cos of 3 into 20 pi into t plus pi by 2. Last frequency, fourth harmonic, 0.5 magnitude means double, 1. No phase angle. So 1 cos of 4 into 20 pi into t with no phase. To convert exponential to trigonometric, all positive frequency take double the magnitude and positive sided frequency angle. DC remains same. DC remains same. That is a trigonometric form expression. That is the third question asked. Of course, we have noted in the last slide only. C bit already we have noted. What is asked in the last bit, sir? If the signal is passed through ideal low pass with cutoff 25 Hz, what would be the steady state response? Yesterday also we have done. If you want to pass the signal through Ideal low pass, cutoff frequency 25 Hz. Ideal low pass filter nature is what? A rectangular spectrum which covers from minus omega C to omega C. Of course, now 50 paisa. As FC is 25 Hz. So which components are passed through the filter? Only first two terms. 4 plus 4 cos of 40 pi t plus pi by 4. Only first two terms are passed through the filter. Yesterday we solved this type of model. Sinusoidal input will guarantee sinusoidal output. Ideal filter means a rectangular spectrum, sir, with gain 1. Okay, I'm moving to next model. Study the question. Two systems are shown in figure. Out of the two systems, which is LTA, every fellow has to respond based on the last problem. Based on the last example only, you can answer this question, sir. For an LTA system, whatever the frequencies we have at the input side, only that frequencies can be retained at the output side. Because LTA system cannot generate new frequencies, sir. LTA system cannot generate new frequencies. Here omega, input and output frequency becomes same. But what happened in the lower ones are input frequency 10, output frequency 5. Not LTA. LTA system cannot generate new frequencies. If some frequencies are present at the input side, that can be passed or suppressed on its own. On its own, LTA system cannot generate new frequencies. क्या हो गया प्रमोद राव? On its own, LTA system cannot generate new frequencies because the middle system is only a filter that can pass or suppress the frequencies. On its own, it cannot generate new frequencies. This is also another easy model. Think of and answer me. Upper one is periodic functions, lower one is the properties of Fourier series spectrum. We have to match the correct pair. Periodic impulse train means again what we'll get, sir? We studied very neatly. Impulse train with strength 1 by T. So A is matched to 2. Full wave rectified sine wave means what we studied. For a full wave rectified sine wave, it contains only even harmonics. Third one, 2 sin A cos B. That must be converted to exponential form. What is 2 sin A cos B means? Sin A plus B plus sin A minus B. Sin A plus B plus sin A minus B, which can be converted to Fourier series form. Our luck is only one option contains that. So without solving, C is linked to 3. 2 sin A cos B must be written as sin A plus B plus sin A minus B. Later on, by comparison, we have to know what is Cn. Our luck is only one option has the chance there. Last one is your favorite. Half wave symmetry. Only odd harmonics are present. Only odd harmonics are present. So A2, B1, C3, D4. That is a pairing. To end the chapter with some easy models, I have chosen last 2 questions. Both are very simple. So the target of this chapter is what? Conversion of non-sinusoid to sinusoid. Take single frequency, generate multiple frequency. That is what mathematically we said as convert omega naught to n omega naught. Convert omega naught to n omega naught. What is disadvantage of Fourier series representation? One disadvantage, this representation is valid only for periodic functions. One disadvantage, the representation is valid only for periodic functions. If you want to get non-periodic function frequency domain, we need a new tool, that is Fourier transform. If you want to know frequency domain content of non-periodic signals, we require Fourier transform. Another disadvantage is system analysis is very difficult with Fourier series. Suppose I have given a simple RC network, sir. I have passed input as 4 cos 2t. I am asking what is the output. Yesterday we discussed a logic. Input coefficient Cn means what is the change in output coefficient, sir? Cn extra multiplied by Hn omega naught. With this logic, if you solve this problem, it is one page solution. 4 cos 2t expanded in terms of exponential series, calculating the system response, omega plus n omega naught. With that logic, if you solve this problem, it will be almost one page solution. But if you solve the same question by Laplace domain, in 2 steps we can complete the problem. If you solve the same question in Laplace domain. The point you have to understand is, everyone, whenever you want to analyze frequency components of the signal, the best tools are Fourier series, Fourier transform. Whenever you want to do system analysis, design of the system, go for Laplace transform and Z transform. Fourier series, periodic function signal analysis. That is what we have done last 2-3 days. Take a periodic signal, draw the spectrum means Fourier series. Non-periodic or aperiodic function frequency domain means which tool we need, sir? Fourier transform. Analog systems are designed in which domain? Laplace. Entire control subject. Block diagram is in which domain? Even state space analysis also S domain. Only when you want to do steady state analysis, then we are using Fourier transform, S plus J omega conversion. Digital system means go for Z transform. Where to use which tool? That clarity I have given. Where to use which tool? Periodic functions frequency domain analysis means go for Fourier series. Non-periodic function frequency domain analysis means Fourier transform. Analog systems Laplace domain, digital systems Z domain. Okay, let us start the new topic. I'm going to next slide, sir. Fourier transform. Listen, everyone, first. Let me complete the discussion. Fourier transform definition generally I will say like this, sir. It is extension of Fourier series for non-periodic signals. It is extension of Fourier series for non-periodic signals. Why that statement is given is already we introduced the word frequency in the last chapter. Already we introduced the word frequency in the last chapter. That concept now we are extending for aperiodic functions. Suppose if you take a decaying exponential, what is the fundamental period of that signal, sir? For decaying, do we have any repetition of the pattern? No, means t is tending to infinity. Or if you take step function, then also what is the time period? No repetition is there as t tends to infinity. As t tends to infinity, omega naught tends to what? As t is tending to infinity, omega naught tends to 0. We observed in Fourier series, we are having a discrete spectrum where the spacing is omega naught. But what happened to that space now? For any non-periodic signal, as capital T tends to infinity, omega naught tends to 0. As omega naught is tending to 0, every impulse is very close to each other. The discrete spectrum of Fourier series is now converted to continuous spectrum in Fourier transform. For any non-periodic signal, as capital T tends to infinity, omega naught tends to 0, every impulse is almost closely spaced. So the discrete spectrum of Fourier series is converted to continuous spectrum in Fourier transform. By modifying Cn formula, we are getting it, sir. We have written Cn as 1 by t, take t on the left side, integral minus t by 2 to plus t by 2, x of t e power minus jn omega naught t dt. In this formula, try to make two modifications. One modification, t is tending to infinity. Another modification, n omega naught replaced as omega. Fourier series definition modified to Fourier transform. So what is limit t tends to infinity tc answer? If you apply t as infinity, what will happen to integration limits? Minus infinity to infinity x of t e power minus j. N omega naught is now replaced as what, sir? Omega t dt. One is t is tending to infinity, minus infinity to infinity, x of t n omega naught replaced as, that is the definition of Fourier transform denoted as capital X omega. So by modifying Fourier series definition, we got Fourier transform definition. That is the reason that statement, extension of Fourier series for non-periodic signals. For any non-periodic signal as capital T tends to infinity, for any non-periodic signal as capital T tends to infinity, omega naught tends to 0, discrete spectrum of Fourier series is converted to continuous spectrum in Fourier transform. Just go through it. Anyway, you should remember definition finally. Just for understanding purpose, I will explain how one topic converted to another topic. So Fourier series, Fourier transform difference is Fourier series strictly periodic functions. Fourier transform can be defined for both periodic and aperiodic functions. Their spectrum discrete, here spectrum continuous. Their spectrum discrete, here spectrum continuous. Nothing is there. How Fourier series definition approximated to Fourier transform. That is what the explanation there, Pratap. Because for a non-periodic signal, if you increase the width of periodic function, so it is tending to infinity. It is tending to infinity. Okay, I'm going to next slide. So that is the definition of Fourier transform. Capital X of omega equals to integral x of t e power minus j omega t dt. That is forward definition, sir. What is inverse definition means? 1 over 2 pi integral x omega e power j omega t d omega. That is inverse Fourier. Every topic contains forward and inverse formulas. Last chapter forward formula is calculation of Cn. Last chapter forward formula is calculation of Cn. What is inverse? If you know Cn, how to get x of t, sir? Sigma Cn e power j n omega naught t. If you know Cn, how to get x of t means sigma Cn e power j n omega naught. Listen. This exponential term is called as kernel or basis function. Actually, the word transform came from general physics. When you have a glass prism, when you pass white light through this one, what is the output we are getting, sir? White light passes through prism. Vibgya. Place the prism in the opposite direction and pass all the colors. What we are recovering back? White light. This is the fundamental principle of any transform. Xt becomes x omega back to xt. So every transform follows this principle only. Without modifying the white light, we are checking the internal frequency components of white light. It contains 7 colors of 7 frequency ranges. That is possible of glass prism. So glass prism is the kernel here. Kernel means it is controlling the signal. The frequency components of the signal are controlled by exponential. What is the controlling signal when we learn convolution, sir? We want to write every signal as sum of impulses. That is a controlling signal. In Fourier series, which are the controlling signals? We want to write the signal as sum of sin theta, cos theta, e power j theta. They are the controlling signals. In the process of extracting frequency components of the signal, they are controlled by exponential term. They are controlled by exponential term. Listen. Omega is the radian frequency. Radians per second are the units. But some fellows, they are habituated to use F symbols. In general, omega equals to 2 pi f. That means what is d omega? 2 pi into df. So d omega by 2 pi is equivalent to df. So what is F style of representation of the definition is like x omega, x of f is used, sir. Integral x of t e power minus j 2 pi ft dt. Directly omega place what I have written, sir? 2 pi f. What is the change in the inverse Fourier? Instead of d omega by 2 pi, what I have to write now? df. So integral capital X of f e power j 2 pi ft df. When you follow f symbol, you can feel they are perfectly dual to each other. But with omega symbol, we have 1 by 2 pi tag. Competitive exam fellows will play with you in both forms, sir. You must be thorough with both forms. Actually, there are two differences between omega and f. Externally, omega is there means 2 pi f is one replacement. 2 pi del omega is equivalent to del f. How it is correct? What is the scaling property of impulse? Recollect, bachas. Del of alpha t means what we have written? 1 by mod alpha del t. Del of alpha t means 1 by mod alpha del t. After cancellation, we are regaining del f. The basic difference between omega symbol and f symbol is these two. Omega plus 2 pi f, 2 pi del omega is equivalent to del f. Omega radian frequency, radians per second. F is the cyclic frequency. Cycles per second are Hertz scale. Cycles per second are Hertz scale. We must be familiar with both notation. Generally, for lab instruments, we'll use F scales. Spectrum analyzer. Spectrum analyzer means we'll say megahertz, gigahertz, like that. Mathematical convenience will enjoy omega symbol. Okay? Just go through the definitions, everyone. This is the largest chapter I am discussing. Fourier transform with applications almost for 13 to 14 hours. According to me, if this topic is over, signal subject is over, sir. Because Laplace, DTFT, jet transform, everything I will compare with Fourier transform chapter only. So learn very carefully CTFT chapter. Very carefully how to learn it. Okay? Just go through the definition, everyone. Suridejai Ruchir. The hardness or simplicity of any topic depends on us. An easy example I'll tell you. If you want to watch the movie, if you like it, you will feel comfortable. If you don't want to watch the movie, it is difficult. This is also same thing. Once we started loving the topics, automatically everything becomes easy. Initial days, everything is difficult only. Okay. When I started studying this subject in the period of 99-2000, Openham Nawab textbook I studied 9 to 11 months on an average 6 hours. How much I know is only 10% of signals that year. After few years, once I started teaching to my friends and my regular teaching career started, after 5-6 batches, I got some simplicity of the subject. As from 20 years I am teaching the same subject, I feel how to play this with this subject in easy manner. So the hardness or difficulty, everything depends on us only. For the first time, for me, it is very difficult because I studied for lengthy period. So nowadays, I am in a position to simplify for 55 to 60 hours only the topics. So according to me, if you love the things you are doing, automatically everything will come to you. Okay. So don't have a wrong thought. I'm asking you specifically. I'm saying this to everyone. What competitive exam needs finally is logical thinking, irrespective of the subject. My favorite topic is op amps. There is vacuum. When I entered into teaching, there is vacuum in coaching centers for signals. So suddenly I started teaching this subject. So whether I am interested or not, I have to show love on it. In the initial days, I am saying, not now. Nowadays, 100% I love it. Because almost every year before Corona, I used to teach at least 18 to 20 batches per annum. 18 to 20 batches. Homestay I have written 2 times GATE, 2001, 2002. 2001 still I have not completed my AMIE. Like BTech, I have done AMIET. We don't have that many engineering colleges when we studied. Only 60 engineering colleges are there in combined Andhra Pradesh. I did not get a good rank, so I have done AMIE. You know the beauty of AMIE? If 100 students write the exam, only 3 fellows will pass. That is the level of the paper. So after that, 2001 I have written, I got 91.1 percentile, sir. That year only 8,000 students have written for EC. I studied for more than 4 to 5 months because only emotion is there with me. Somehow I have to crack the score. But 2002, IISc Bangalore, you believe me or not, I used to teach 5 to 6 subjects. 5 to 6 subjects. So just for 15 days I studied and I got 98 percentile. We have percentile system and around 450 rank. Then I completed my master's in signal processing. So what is the difference in 2 years, 2001 and 2002 is, 2001 I have only emotion. Somehow I have to crack it. 2002 I have concepts. Because I used to teach 5 to 6 subjects, I have good concepts. I improved myself. That's what I'm saying. If you show interest, it will come to you. If you do overaction, nothing will come to you. Concepts are most important, especially for GATE exam, ISRO paper, BARC exam. Okay. ESC somehow chalta. Syllabus may be more, but GATE exam, ISRO, BARC, these exams, you have to work hard with logic. Pavan, whatever is important, I will make a point. I'm writing also. If you see the last slides, if it is important point, I will write it very clearly. Okay. Anyway, I'll provide my review notes also, handwritten notes. I already informed to that fellow. I think he has not uploaded. What to remember in each topic, that review notes is there. Maybe by tomorrow he will upload it. I have informed already. Okay. Let us not waste our time. Just a minute. Think of the left side question first, sir. If xt is a voltage waveform, what are the units of x of f? Just now you have noted down x of f formula, see it and respond. Already x of f is available with you. By looking at x of f definition, tell me what are its units. Xt is voltage signal. What are the units of its Fourier transform? Voltage signal means volts. Exponential, no dimensions. Integration done with respect to time, time minutes, seconds. Volt into second or volts per hertz. Voltage signal means volts. Exponential has no dimensions. Integration done with respect to time, time units are second. Volt into second or volts per hertz. How to answer this? Some signal is given, find capital X0 and integral x omega d omega. Signal graph covers from -1 to 3, sir. According to the definition of Fourier transform, what is the meaning of capital X0, sir? In the definition, if I substitute omega place 0, what will happen on the right side? In the definition, if I substitute omega place 0, it is area under the signal. It is area under the signal. Directly in the Fourier transform definition, substitute omega place 0, sir. Substitute omega place 0. So what is the area under the signal means? Combine this portion such that it will look like rectangle. What is rectangular part area? 4 into 2. From that remove triangular part area. Half base height. Make the given shape as rectangle, from that remove triangular part area. Answer 7. Answer 7. How to answer the second bit is, it is linked to inverse Fourier definition, sir. See here, 1 over 2 pi integral x omega e power j omega t d omega. You want integral x omega d omega means make this exponential as 1. How to make exponential as 1, sir? T place 0. T place 0. So it becomes 2 pi into x of t checked at t equals to 0. In the inverse Fourier definition, substitute t place 0. So what is small x0? Signal amplitude at 0, how much, sir? 2. 2 pi into 2. 2 pi into 2. Actually, from these two bits, we have to make one observation, sir. Area under time domain signal means where we have observed the spectrum. Area under time domain signal means where we observed the spectrum, sir, at origin. Area under frequency domain means where we have taken signal at origin or not. So when you are observing area under one domain, you are checking other domain at origin or not. When you are checking area under one domain, you are checking other domain at origin. Area under one domain corresponds to observing other domain at origin. Area under one domain corresponds to observing other domain at origin. What is the meaning of one domain and other domain, sir? Time domain and frequency domain. Whenever integration of the signal is asked, you should get the idea, take its spectrum at origin. Integration of the spectrum is asked means, what is the idea you require, sir? Take the signal at origin. Take the signal at origin. Area under one domain corresponds to checking other domain at origin. Okay. Let me discuss the next point. That is convergence of Fourier transform. Convergence means when the Fourier transform answer is finite. When the Fourier transform answer is finite. Listen first, sir, everyone. If I take magnitude to the definition of Fourier transform, if I take modulus, what will happen on the right side? Magnitude of e power minus j theta is 1. Magnitude of e power minus j theta is 1. So it becomes what, sir? Integral mod xt dt. Integral mod xt dt less than infinity. If the absolute area under the signal is finite, then we may define Fourier transform. It is only a sufficient condition. It is not a necessary condition, not compulsory. Why it is sufficient means for signals like cos function and step function, this condition is failed, sir. Still we are taking its transform. Integration of modulus of cos means infinity. Integration of modulus of u of t also infinity. Even this condition fails. How we are defining Fourier transform of these signals means they are power signals. They are power signals. Power signals expects infinite energy. Power signals expects infinite energy. True generation of any power signal is not possible. True generation of power signal is not possible because it is asking for infinite energy. When you say cosine function extends from minus infinity to plus infinity, sir, who observed minus infinity? We don't know. Before our birth, it is minus infinity. What is plus infinity? Once you reach to steady state, you will know it. Okay? There is no physical meaning of defining minus infinity to infinity. That is what one parameter in controls we are learning as settling time. No practical system is really asking for infinite time for making output as input. Practical cases 4 seconds to 5 seconds. When you study analog, we will say 1 microsecond or 2 milliseconds like that. As we are easy fellows, without giving input only, we want the output because we are doing maximum small signal analysis. Correct or not? So what is the main point you have to understand is when you are defining Fourier transform of power signals, they have mathematical perspective. It is not compulsory condition. So without confusion, I am giving total 3 statements on convergence. First point is Fourier transform is defined for stable and energy signals. That is the first point. Second point, Fourier transform of power signals is defined as approximation to energy signals or impulse functions are permitted in its transform. Fourier transform of power signals is defined as approximation to energy signals or impulse functions are permitted in its transform or spectrum. I will explain this second point in few minutes. I'll give clarity. Second point. Third point, Fourier transform is not defined for neither absolutely integrable nor square integrable signals. Absolute integration means integral mod xt dt, sir. Square integration means energy. Integral mod xt whole square is called as energy. The examples of last point are ramp t times ut. It fails both conditions. It is not absolutely integrable nor square integrable. Or a growing exponential e power 2t ut. For these signals, we cannot define Fourier transform, but we can define Laplace or not. Laplace of ramp 1 by s square, this is 1 by s minus 2 like that. So this is not a compulsory condition. By doing approximation also, we can define Fourier transform. Fourier series we have done approximation, Fourier transform also we are doing approximation. Just go through the 3 statements there. Fourier transform is defined for stable and energy signals. Power signals, it is defined as approximation to energy signals or impulse functions are permitted in its spectrum. Impulse functions are permitted in its spectrum. I will explain the second point in few minutes. What, Mohammed? What you want to say? What either? Without these 3 points in a single line, you can say physical possibility is the valid condition for existence of Fourier transform. Any signal that is generated in the lab, its spectrum also has a meaning. Physical generation. is the valid condition for the existence of Fourier transform. For a lab generated signal, if you take its spectrum, it has a meaning. Otherwise, it is a mathematical expression. Simple way to say it. Okay. Let us discuss Fourier transform of certain standard signals here. I am going to next slide. First signal is a decaying exponential e power minus at ut. First one is a decaying exponential e power minus at u of t. Neither nor correct, Mohammed. What are the integration limits to be varied there? 0 to infinity, signal e power minus at multiplied by e power minus j omega t dt. With a positive side signal. So further, e power minus of a plus j omega into t. So e power minus of a plus j omega into t by minus a plus j omega over the limits 0 to infinity. T place infinity 0, t place 0, 1. So what is the resultant answer, sir? 1 by a plus j omega. 1 by a plus j omega. Decaying exponential transform pair with 1 by a plus j omega. So textbooks we are denoting like this, sir. Double-sided arrow. That is called as Fourier transform pair. Pair means there is one-to-one correspondence between time domain and frequency domain, sir. Whenever this is the signal, spectrum is 1 by a plus j omega. Whenever 1 by a plus j omega is the spectrum, time domain signal is e power minus at ut. It is both the ways. We have one-to-one correspondence between time domain and frequency domain. Let us draw the shape of magnitude and phase spectrum, sir. Modulus of x1 of omega equals to what? 1 by root a square plus omega square. Let us draw the graph roughly, sir. Because the other term is a square, I am assuming omega as multiples of a. Suno. Omega 0, 1 by a plus or minus it is 1 by root 2 a square plus or minus 2a 1 by a root 5, like that till infinity. If you combine all those points, roughly that is the shape of the curve. What about angle here, sir? 1 by a plus j omega means what is angle? Minus tan inverse of omega by a. Try to verify the same points. Omega 0 means 0. Omega a means tan inverse 1 with negative sign, minus pi by 4, minus 8 becomes plus pi by 4. Omega 2 means around 63. Like that, highest frequency that is possible is plus or minus infinity, where it is going to plus or minus pi by 2. That is a rough shape of the curve, sir. Rough shape. So magnitude spectrum is even symmetric, phase is odd symmetric, means combinedly we call that as Wood symmetry, sir. Yesterday only we studied it. Magnitude even symmetric, phase is odd, combined it is called as conjugate or Hermitian symmetry. Conjugate or Hermitian symmetry. Fourier transform of a real valued signal exhibits conjugate symmetry. Fourier transform of a real valued. Real valued means any instant of time the amplitude of the signal is real numbers are. At any instant of time the amplitude of that signal is real number. Fourier transform of a real valued signal exhibits conjugate symmetry. What is the advantage of the spectrum? At every frequency, we can visualize the magnitude and phase. And you can also observe up to what range of frequencies the maximum energy is concentrated. Up to what range of frequencies the maximum energy is concentrated. See, sir, decaying exponential can be generated due to simple RC network. It is a known example for you. What is the transfer function of this one? 1 by 1 plus j omega RC. If I take RC common, it is like j omega plus 1 by RC, which is like our formula. A is 1 by RC. We are adjusting, A means what actually we are adjusting? RC components. How to take RC elements such that within the low frequencies we will get the peak energy. That generation of signals only you have learned in analog. Suppose I am defining Fourier transform of rectangle. Multivibrator is needed. Decaying exponential may be possible due to RC network. Sketching of magnitude phase spectrum is Bode and Nyquist plot controls. Of course, asymptotic plot in the case of Bode. Okay, sketching of magnitude and phase spectrum. In signals, what we are doing is, if you know the signal, get the spectrum. So if you think in a proper manner, engineering is a single subject. Generation of signals is analog circuits or network theory. Okay, finding the spectrum is signals subject. Graphically, if you want to check the magnitude and phase spectrum, we are going for controls. Correct or not? For every signal for which we are defining spectrum, the physical generation is possible because of a circuit. That is what you have learned in analog already. Okay, that is the first signal, decaying exponential transform pair with 1 by A plus j omega. So I'm going to next slide. If I take the second signal as e power at u minus t with a positive, of course, It is a growing exponential for negative time. Multiplied by u minus t means it covers negative times, sir. Growing exponential. How to get Fourier transform of this function? Do we have any link between this signal and previous signals, sir? Do we have any link between x2t and x1t? Any link is there or not? x2 of t is looking like folded version of x1t. Yeah? x2 of t is looking like folded version of x1t or not? Simply take flipped form of the signal, which is x2t. So let us apply the time reversal property of Fourier. X minus t is having spectrum as x minus omega. If t replaced as omega, minus t replaced as minus omega. If t is replaced as omega, minus t replaced as minus omega. So x2 of omega equals to x1 of minus omega. In the previous spectrum answer, omega replaced as minus omega. In the previous spectrum answer, omega replaced as minus omega. So answer is 1 by a minus j omega. 1 by a minus j omega. Directly apply reversal property of Fourier transform. Directly apply reversal property. Previous answer 1 by a plus j omega. Now it becomes 1 by a minus j omega. Which spectrum changes now, sir? Magnitude spectrum or phase spectrum? Which spectrum changes? Magnitude is same. Phase angle becomes plus tan inverse of omega by a. When you apply time reversal property, only phase spectrum changes. Magnitude remains same. Only phase spectrum changes. By the application of time reversal property, phase spectrum changes. Magnitude remains same. Everyone think of what is sum of previous signal and this signal, sir. If you add decaying and growing exponential, it is named as which function? Sum of decaying and growing. That is named as which function, sir? Tell me. Just add both the functions. Gaussian, bachas. Two-sided or double-edged exponential. E power minus a mod t. That is called as double-edged or two-sided exponential. Funny fellows, Gaussian has some curvature. That to its expression e power minus at square. E power minus at square equals to e power minus a mod t. Sum of decaying and growing exponentially is called as two-sided or double-edged exponential. Both sides it is there. Two-sided or double-edged exponential. Signals are added means the respective spectrums are also added. Fourier transform, first one 1 by a plus j omega. Second one 1 by a minus j omega. New result becomes what, sir? 2a by a square plus omega square. 2a by a square plus omega square. E power minus a mod t is having Fourier transform as 2a by a square plus omega square. In this problem, one more modification. In the place of plus, suppose if I take minus sign, what will happen? I highlighted with green color pen, sir. In the place of plus, suppose I am taking minus sign. Let us see what will happen. Okay. y2 of t, let us name that signal as y2 of t, e power minus at ut minus e power at u of minus t. Which is like this. So what is the Fourier transform answer now, sir? Middle minus sign, if you take middle minus, numerator changes to what? Minus 2j omega. In the last slide, middle minus sign you take, it becomes minus 2j omega by a square plus omega square or not? What, Kiran Kumar? What a great idea. I did not get such ideas. E power at u minus t, here it stops. E power minus at ut, here it starts. Even if you feel there jump half plus half is 1 only, na? What type of great ideas you are getting here? Even if you feel they are discontinuous at origin, half plus half becomes 1 only, na? Huh? Okay. By taking middle minus sign, we got the answer as minus 2j omega by a square plus omega square. What is limit a tends to 0 y2 of t? If I substitute a plus 0, that is treated as which function? Ut minus u of minus t. Which functions are? U of t added to minus u of minus t is which function for us? Signum. By substituting a plus 0, the curvature is converted to constant amplitude of plus or minus 1. Do the same approximation in its transform, sir. If you substitute a plus 0 in the transform, what will happen? Minus 2j omega by omega square, that is minus 2j by omega. Signum Fourier transform pair with Signum Fourier transform pair with 2 by j omega. Signum Fourier transform pair with 2 by j. If you substitute a plus 0, the expression becomes ut minus u of minus t, which we know as signum. Do the same approximation in its Fourier transform, we got this result. So signum Fourier transform pair with 2 by j omega. Signum function is a power signal. Signum function is a power signal because it is maintaining constant amplitude of plus or minus 1 for infinite length. Everyone see your notes. What is the second point we stated in convergence? See your notes, sir. Fourier transform of power signals is defined as approximation to energy signals. Originally decaying and growing. Originally decaying and growing, they are energy signals. What approximation we have done, sir? Substituting a place 0. Substituting a place 0. Energy signal approximated to power signal. Only by mathematical approximation we got the answer, sir. Only by mathematical approximation. If you solve from direct definition, you will get answer as infinity. If you solve from direct definition. You may get a doubt, what is the need of doing this approximation? Because of this formula only we got the thought of Hilbert transform, 90 degrees phase shifter. Because of this formula only we got the thought of Hilbert transform, 90 degrees phase shifter. Okay. Actually, one point we have to observe is two-sided exponential is a real and even signal. The respective spectrum also real and even. Two-sided exponential is real and even. Respective spectrum is also what, sir? Real and even. Signum is real and odd. The spectrum is imaginary and odd. We have j term means imaginary. Because of j, you will get plus or minus 90. Depends on whether positive frequency or negative frequency. Real and odd becomes imaginary odd. Previous slide, what statement I have made, sir? Real and even is real and even. Real and even is real and even. This slide, what we have made? Real and odd is imaginary odd. Let me simplify this concept. How to remember these points easy manner. Everyone see how I am preparing. See here. Take two blocks. Even, odd. Even, odd. One side it is time domain, the other side frequency domain. On the lower side, interchange the blocks, sir. Odd, even. Odd, even. Interchange the blocks. Real, real, imaginary, left side it is time domain, right side it is frequency domain. See here, everyone. Real and even in time domain is what? When you take real and even in time, frequency domain also same answer, we verified. Real and odd in time domain becomes what, sir? Real and odd in time domain becomes imaginary odd. Vice versa. Opposite also true. Imaginary odd becomes real and odd. Imaginary even becomes imaginary even. Recent competitive exams, these questions are asked regularly, theoretically. Real and even becomes real and even. Real and odd becomes imaginary odd. Vice versa. Imaginary even becomes imaginary even. For the last combination, still I have to give an example. How imaginary even becomes imaginary even. For the last combination, sir. See, mathematically we are solving, from that theoretical conclusion we are making. In all my discussion, first I will solve the problem, then I will give conclusion, sir. From theory, I will never solve problem. From problem, I will give theoretical statement for you. Just real signal means conjugate symmetry. Just real. But that real signal can be separately real and even, real and odd. Separately. WSK, you are from which university? I hope you have completed the table. Acha. What you have done, sir? You are working now somewhere? Everyone see your notes. From first formula, we have created 4 formulas. Decaying exponential 1 by a plus j omega. Decaying exponential. By folding it, we converted that to increasing exponential. By adding both the signals, we have made that as two-sided. Subtraction with an approximation, it is converted to signum. Out of the 4 formulas we studied, the first formula is reference. Very good, Ravi. The first formula is reference. First we have selected decaying. By folding it, it is converted to increasing. By adding both the signals, it becomes two-sided. Subtraction with an approximation, it is converted to signum function. Okay. Rest part. This is known for every fellow. What is the Fourier transform of impulse function? Response, sir. What is the Fourier transform of impulse? According to the sampling property of impulse function, impulse exists at 0, e power 0 is 1. The spectrum of impulse is constant for all frequencies. The spectrum of impulse is constant for all frequencies. From the sampling property of impulse, we are saying it's a from the sampling property. Out of the available signals, impulse is the only signal that contains all frequencies equally. You take any frequency, its magnitude is 1 only. It is equally distributed everywhere. Out of all the signals, impulse is the only signal which contains all frequencies equally. What is the Laplace of impulse function? We know 1. Jet transform of impulse is also 1. So any transform of impulse is 1 only. This funny question is asked in one of the ESE objectives. Which of the following signal has all transforms same? Impulse. For impulse, everywhere transform is 1. In communication, what we are learning? Power spectral density of white noise is constant. Autocorrelation is an impulse or not? N0 by 2, N0 by 2 delta. Power spectral density of white noise is constant. Respect to autocorrelation is an impulse. Please try this question, everyone. What is the inverse Fourier transform of this expression omega square plus 12 by omega square plus 9. According to the formulas we derived till now, please cross check which denominator has the terms there. According to the formulas we derived till now, please cross check which denominator has the term omega square plus a square form, two-sided exponential. Please refer your notes, bachas. Omega square plus a square is for two-sided exponential. Carry on. Get the inverse. Numerator, denominator powers are equal, so it is proper function. First you perform division. So it becomes 1 plus 3 by omega square plus 9. But what is the formula style, sir? E power minus a mod t is 2a by s square plus omega square. Denominator can be written as omega square plus 3 square. But numerator we want 2a, which is not there. 2a is not there. Adjust it. Constant becomes impulse. 2a by a square plus omega square is what? E power minus a mod t. E power minus a mod t. We want 2 extra in the numerator, sir, because 2a by a square plus omega square is our relation. So adjustment of 1 by 2. Okay. Convert the proper function to strictly proper by division. Proper means numerator denominator powers are equal, means it is proper, sir. If denominator power is more than numerator, that is called as strictly proper. If denominator power is more than numerator power, the word strictly proper is used. Similarly, if I ask this question, what is the inverse Fourier transform of this expression? 1 by 3 minus omega square plus j4 omega. Based on the formulas we learned till now, on that only I have given for you. Simple thought you require is minus omega square can be adjusted as j omega whole square. Then only further enjoyment is possible for you. Minus omega square can be written as j omega whole square. So denominator is like x square plus 4x plus 3. It becomes j omega plus 1 into j omega plus 3. So what is the partial fraction enjoyment here? J omega plus minus 1 means 1 by 2 residue. J omega plus minus 3 means minus 1 by 2, sir. So 1 by a plus j omega is Fourier of which function? Decaying. 1 by a plus j omega means is it decaying? Exponential. Adjust minus omega square at j omega whole square. Denominator is looking like x square plus 4x plus 3. That is x plus 1 into x plus 3. X plus 1 into x plus 3. Partial fraction enjoyment, get the result. What is the Fourier transform of a rectangular pulse? Theoretically, to say rectangle in time is sap function or sinc function in frequency, sir. Theoretically, to say rectangle in time domain corresponds to sap function or sinc function in frequency domain. Listen first. Of course, rectangle is a finite length signal which covers from minus t by 2 to plus t by 2 with amplitude A. So the integration limits to be varied are minus t by 2 to plus t by 2 a e power minus j omega t dt. Further, a e power minus j omega t by minus j omega over the limits. So a by j omega e power j omega t by 2 minus e power minus j omega t by 2. What extra term we need to write that as signs are? 2 is needed. So this e power j theta minus e power minus j theta by 2j means, what is the new answer we are writing? 2a by omega sin omega t by 2. 2a by omega sin omega t by 2. Let me complete. I will come back to this slide. Don't be emotional. Okay. This answer we have chance of adjusting in two forms. This answer we have chance of adjusting in two forms, sir. One is called as sap function, sin x by x. Actual expansion of the word sap function is sin function over its argument. Sin function over its argument, shortcut sap function. It can be also adjusted as a sinc pulse, sin cardinal. Sinc pulse means sin cardinal, that is sin pi x by pi x. How to write sinc pulse in terms of sap function is SA of pi x. X place, if I substitute pi x, that is giving back sinc pulse. Most of the fellows will take sinc x as sin x by x, that is wrong notation. Sinc pulse should always contain pi symbol. Be careful, sir. Sinc pulse should always contain pi symbol in its notation. Pi 3, pi by 2, anything will work out. So if you want to convert this answer to sap function or sinc function, what extra I need? If I want sap function in the denominator, sin x by x form. Sin x by x form. So that is 2a sin omega t by 2 by omega t by 2. We need omega t by 2 in the denominator. So what extra adjusted, sir? T by 2 multiplied by 2 by t. What is this quantity sin x by x? At SA omega t by 2 or At sinc omega t by 2 pi. To convert SAP function to sinc function, this is the formula. Pi x equals to lambda means x becomes lambda by pi. X becomes lambda by pi. Both relations are correct. Both relations are correct. First, you go through the steps, sir. Go through the steps. First, you have it where theoretically, sir, rectangle in time domain corresponds to SAP function or sinc function in frequency domain. What happened here? So many fellows are flickering. Internet problem, huh? From last 10 minutes, people are leaving, joining. Or you are playing game for fun. First, we got 2a by omega sine omega t by 2. This answer we have chance of adjusting in two forms, either SAP function or sinc function, sir. SAC. SA, SA. Sine over its argument is its expansion. क्या रे मोहम्मद क्या पूछ रहे? Other one sinc SINC sine cardinal. Okay, this is the conversion where it is converted to SAP function or sinc function. But let us see the graph. How the graph will be there. Of course, our SAP function is product of sin x and 1 by x. Sin x is an oscillating signal like this. That is extra multiplied by 1 by x. 1 by x is like this. As x increases, 1 by x decreases. Once you take product of them, resultant graph may look like this. As the denominator increases, our oscillations are go on reducing. Of course, limit extends to 0, sin x by x is 1. Every fellow knows it. Indeterminate condition means 0 by 0. If you get what you will do? L hospital. So limit extends to 0, sin x by x is 1. For some values of x, the result becomes 0. Generally for multiples of pi. So this is the rough graph of SAP function sin x by x. Rough graph. Sin x multiplied by 1 by x. As the denominator increases, the number of oscillations are go on reducing as denominator increases. But in our case, what is the result, sir? Before converting that to SAP function or sinc function, what is the result we got? In our case, this result. Sin x equals to 0 means what is the general solution? Plus or minus n pi. So in our case, for integer multiples of 2 pi by t, result becomes 0. In our case, the answer becomes 0 for integer multiple of 2 pi by t. First, everyone go through this graph. So when you try to draw the spectrum in our case, for integer multiples of 2 pi by t, we are making the result 0 for integer multiples of 2 pi by t, sir. So the graph will look like this. For all integer multiples of 2 pi by t, our spectrum becomes 0, maintaining maximum amplitude at origin. Of course, it is a Fourier transform rectangle, symmetrical rectangle. Just now we stated a point, if the signal is real and even, spectrum is real and even. It is obeyed in the case of rectangular, not sir. Signal is real and even means spectrum is real and even, 100% satisfied. That is one point of observation. Another point is, area under the signal means we have to check spectrum at origin. What is the area under this rectangle, sir? What is the area under rectangle? AT. So take spectrum at origin, that is also AT. Area under time domain function means take the spectrum at origin, that is also satisfied. Area under signal corresponds to verify the spectrum at origin. What is the bandwidth of the spectrum, sir? Ideal bandwidth is infinity. Ideal bandwidth infinity. But its maximum energy is concentrated within the main lobe width. Some of the energy is wasted due to side lobes. So the practical bandwidth is 2 pi by t. Bandwidth definition is strictly valid for positive range of frequencies, sir. Ideal bandwidth infinity. Practical bandwidth is 2 pi by t. If we are including negative frequency also into consideration, it is called as spectral width. Why negative frequency is included in the spectrum? We know the answer for it. To reproduce original real component. If we take negative frequency also into consideration, the spectral width becomes 4 pi by t. What is null to null or zero crossing bandwidth, sir, for the same spectrum? What is null to null or zero crossing bandwidth for the same spectrum? Where the spectrum crosses first time 0 at 2 pi by t, immediately it crosses at 4 pi by t. So that width is how much? Null to null bandwidth or zero crossing bandwidth is 2 pi by t. First zero crossing at 2 pi by t, next zero crossing at 4 pi by T. Can a signal be time limited and band limited simultaneously, sir? Is it possible for us to take finite length in both domains, time domain and frequency domain? If it is possible, no need of studying this topic. They can be infinite length in both domains, which are our starting problems, but they cannot be finite length in both domains. A signal cannot be time limited and band limited simultaneously. A signal cannot be time limited and band limited simultaneously. That is what generally we'll say narrow band in one domain is wide band in other domain. A signal cannot be time limited and band limited simultaneously. There is a concept called as array signal processing, sir. We are transmitting the signal data in the form of ones and zeros, that is rectangular pulse. Enemy person should not enter our zone. So we have to see that the maximum energy must be there within the main lobe. If some of the energy is wasted due to side lobes, the enemy person may enter into our zone. That is called as radar signal processing. Okay. Kiran Kumar, our beginning signals are also infinite length. Decaying exponential infinite length. Spectrum also infinite length. I am saying they cannot be finite length in both domains. As we are using this formula multiple times in our discussion, what is a simple way to remember this formula? Everyone see here. Simple way. Whenever you take a symmetrical rectangle, sir, its Fourier transform answer is what? AT SA omega by 2. AT is nothing but area under the rectangle. AT is area. SA of omega, internal T by 2 corresponds to what, sir? Positive width of the rectangle. Instead of by hearting it, whenever you take a symmetrical rectangle, how to write spectrum directly? AT corresponds to area. SA of omega frequency domain. Internal T by 2 is positive width of the rectangle. Internal T by 2 is positive width of the rectangle. Now everyone tell me with this logic. Suppose I have given a rectangle from -4 to 4 with amplitude 5. How to write the answer directly, sir? Rectangle from -4 to 4 with amplitude 5. It is symmetrical. First area, 5 8s are 40 here. 5 8s are 40. SA of omega into positive width. What is the positive width? Positive width of the rectangle is 4 or not? First take area 40, SA of omega into positive width is 4. Otherwise, we have to do comparisons, sir. A value 5, T by 2 4, power action. Here you have to substitute. That is time waste and lengthy. Simply take area 40, SA of omega into positive width. Apply this only for symmetrical rectangle, not for this graph. Not for this one. If you want Fourier transform of YT, sir, first you take its symmetrical form, later on some property. First you have to take its symmetrical form, later on maybe shifting or scaling. One more time I am repeating. Whenever you take a symmetrical rectangle, AT stands for area. SA of omega internal T by 2 multiplier is positive width. Internal T by 2 multiplier is positive width of the rectangle. Okay. At least 20-25 problems I will solve on this function. Be careful. 20-25 models. Multiple times you'll use the signal, sir. The list of formulas, you must be thorough in the chapter. I am providing the table for you. Just have a glance of the table for tomorrow's class, sir. Okay. Just I am adding the table for you. These are the standard pairs. You must be thorough. Yes, Kiran Kumar. Not only communication. Logic 1, logic 0 means automatically rectangle. Spectrum is SAS spectrum or sync. So be thorough with this relation. Okay. Tomorrow's session is from 7 to 1. One small request. On Monday, I am taking the session from 4:30 to 6:30 instead of 5 o'clock, sir. Only Monday. Please bear with me. Only on Monday. Tomorrow, 7 o'clock, I will start the session. Today, we discussed only 5-6 formulas. Tomorrow, some more relations we are going to discuss. That's all for today. Good night. Tanuja, I am sending the file immediately to that fellow. I don't know what that fellow is doing for in charge. Today, I will inform one more time. Immediately, once class is over, within 5 minutes, that file is available with that fellow. He has to upload from his side. Okay.